And without any further ado, it's time for me to bring my guests on the show. So we have Rohit and we have Matthias. Welcome, friends. How are you?
Hello.
Hola.
Oh, hola. Now you're throwing people off. You are based in Europe, and you're not Spanish, Rohit, right? Are you Spanish? No.
No, I'm not. I'm based out of London. I'm taking this
Oh, you're in
conference from my
London.
bedroom.
I thought you were in the Netherlands.
No.
Okay. London. How's things in London these days with COVID and all that stuff?
You know, the cases count is high.
Oh
And
yeah.
even I'm quarantining, so I'm in my room, logged, doing the show for you from my bedroom.
People drop food outside your door and then just walk out. Is that it?
That's right.
Oh man. And Matthias is based in beautiful Seattle. He's actually a close neighbor of me. Although I've never been to your neighborhood, like your house. But
No,
that will happen.
well, we can open the fence once in a while.
Are you isolating as well? Because you were a little bit unwell last week, right? You're feeling well now, right? All good?
I'm good enough. I'm happy to be here.
Excellent. Now, introduce yourselves a little bit for our audience so they know who you are and what you're doing at Microsoft.
Okay, I'll start first. So I'm Rohit Gulati. I'm a program manager in Identity and Network Access Engineering. I work on Decentralized Identifier and Verifiable Credentials. I'm based out of London, and my charter is to work with customers and partners in the EMEA region. That's me. Over to you, Matthias.
All right, Matthijs Hoekstra. We always introduce myself. I'm Rohi's twin brother. So we both work as a PM in the identity org, right? And we help our customers and partners to implement the identity platform, so to say. We're focusing on decentralized identities, verifiable credentials mostly right now. But yeah, we have broad knowledge about the platform. The zero trust trading, some of the content might actually be from me, so it's kind of nice.
You're the man, my friends. Yeah, so Matthias used to be in my team when I joined, and then as soon as I joined, he left. I don't know if that was a coincidence or not, but it happened. So he used to be a developer advocate working with you guys, but he's got, you both have fantastic knowledge on Azure Active Directory. So there's been a lot of conversation out there, and there's a lot of discussion about Web3, blockchain, NFTs, and now decentralized. Everything is decentralized, or everything is moving to a decentralized phase. So let's start with what is a decentralized identity and why should we care about it? Who wants to take that? Rohit, you want to go?
All right. I'll start by doing a definition so that it's easy for everyone to understand and it will set the baseline. Matthias and I, when we do these presentations or conversations, DID and verifiable credentials, sometimes it gets used interchangeably, but decentralized identifiers are user-generated identifiers, self-owned by the user. These are globally unique identifiers, and these will be rooted in a decentralized system. In our case at Microsoft, we are using IAM, which is the Identity Overlay Network. And when I talk about DID, the user will take the ownership of DID by doing some signing of the messages using the keys, and all of it goes into something called as a DID document. So we'll talk about that. So I don't know if this give you so decentralized identifiers are user generated, and these are self-owned, and these are globally unique identifiers.
Yeah, I guess if you want to summarize the differences, I hope by now everybody on this show knows what identity and access tokens are, if they have listened to Christus good enough.
I hope so, yeah.
It's typically a central authority handing those out and controlling those. In our case, it's Azure Active Directory or B2C, but it could be any IDP, but it's a central system. You go to that central system, you do some kind of little dance, and they give you back after you've done that successfully ID tokens and access tokens. I think the biggest difference between the centralized kind of system and what we're going to talk about as a decentralized system is that think about it as you yourself being your own IDP. So when Rohit says like, oh, I'm going to create my own things, that means that you're going to literally issue your own identifiers, your own tokens, or whatever you want to call it. It's not exactly the same tokens, but conceptually wise, you are your own self-issued IDP.
Yes. Okay.
That sounds interesting. So how do you know how you can trust each other and doing all that kind of stuff? That's actually something they thought about, and we're going to talk about it as well. But that's the biggest difference. So think about you being your own IDP, and you carry that along with you in your or on your phone.
So right now, if I open my password manager, I probably have some like 870 passwords and different websites I've used in the past. How is that going to change with verifiable credentials? Will I still need to have the 870 verifiable credentials for each of the vendors I interact with? Or can I use the same one and present it to them and they can verify it somehow?
Right now, it will, you're not going to rewrite the internet overnight. So for now, you're going to have your 800 passwords and your 500 different identities, crystals by day, Flappy Bird by night, all that kind of stuff.
Okay.
That will be the same. At some point in the future, what we want to do with this technology is that we want the user to be in control of their own identity.
Sure.
Think about this. You don't control and own the identity you use in your Microsoft account, your Gmail account, your Facebook account. You lease that identity.
Yes.
Right? And you lease that identity, and that's why you can access those services. But at any point in time, somebody else, not you, can decide to kill or cancel that account.
Or use it for whatever reason, right? They can sell the data to someone else.
Or you post the wrong thing, or you share this, you share something stupid from your aunt. That you don't control that.
Yeah.
So with this technology, what we know, we want you to be controlling your own identity, and you can call it account, persona, doesn't really matter. And you use those identities to access those resources. They might still, deny you access to those resources. But the thing is that you own those, and you can call it accounts, identities, doesn't really matter. But the idea is that the user is in control of those, and they decide what they want to use, where and how, and what kind of information they want to be able to share and whatnot. That's the premise I actually from this new decentralized world.
Yeah, and I like the way our engineering leader says it's an evolution journey, not revolution. So. Which means you talked to me about 500 identities that you store, but can I use some logic from there, stamp it in my verifiable credential, and then reuse it? So slowly systems will move, but the things will evolve by time. And just extending to what Matthias was explaining, you have identities given to you by 500 different identity providers. They have this authority to block you. What it means is it also takes away all the history that you had. And if you had used your Google identity against an application and your Google ID is blocked, you also lose access to that application. So all that thing can be controlled in this way. I, as a user, I own my own identity. And as a concept, I choose to decide what I would like to present to the application. That's the whole premise of decentralized identity.
Yeah, and that's a very good example because for people that use social media to sign in, it was like 2 months ago when Facebook went down for whatever reason, and then a lot of people were unable to access unrelated services to Facebook only because they were using Facebook to sign in. So you have a dependency now on an external service that you don't even own. So going back to, we have verifiable credentials. So I get my verifiable credential, which is great. That means that the benefit there is that I own the data, right? I own the credential, and then if I want to revoke it for whatever reason and stop dealing with a vendor or a website, then I own the data. And then I can also choose the metadata that I want to share as part of the verifiable credential, right? So I might not want to share the age or my address or other metadata that are attached to the verifiable credential, but other vendors may need them. So I choose how that works, which is great.
Yeah.
So
you're correct. So let's talk about what's the difference between a verifiable credential and a decentralized identity or a decentralized identifier, because we have used both terms now, and I'm not sure if people on tuning into the show know what the difference is.
That's right.
So let's start with decentralized identifiers. No, maybe do it the other way around.
Let's start with
We
the
can
VC.
actually-
Yeah, take an
Yeah, let's go
example
with
of driving
VC.
license.
Yeah. Yeah.
Let's talk about the driving license then. Yeah. So
Cool.
so verifiable credential. What we say is it's a set of data objects that consist of claims, and these are a set of claims that are issued and attested by an issuer to a subject. Think of like a driving license. It is issued to you by a driving license authority, and it has details like your first name, last name, your date of birth, your address, and are you certified to drive a type of vehicle, and till when. So it's a set of attributes, claims that are given to you by an attested issuer, and all this concept is packaged. So it's a data object which is a set of claims that are available to a user, to a subject, and it is issued to a subject. So while if you look at it, it is represented by a DID or a decentralized identifier. Issuer signs the verifiable credential as a proof, and they attest that information for that identifier. So as a user, uh, I am getting a verifiable credential which has a bunch of claims in it, and it is signed by the issuer. And in that whole mix, if you see, the issuer has a set of keys that it uses, and all these information are then linked to a decentralized identifier. So issuer's DID uh, will be then used to sign that credential, and the issuer will sign it using its private key. So that's the whole concept around decentralized identifier and verifiable credential.
I
Does that
can
make
I can
sense?
quickly show what it looks like and what it actually is.
Yeah.
Yeah.
So
Okay,
we can
let's
be,
do
we
that,
can
yeah.
be nerdy here, right?
Yes,
Yeah,
absolutely.
let's do
Okay.
But before we do that, we do have a question from the audience. Bolt is asking, do you think that decentralized identity will evolve into a masking mechanism, like how Apple allows you to have an anonymous email ID in between you and the provider?
Yeah, I think yes. Well, it's probably going to be manifesting itself a bit different than that, but yes,
Okay.
I think when you are in control of your identities, and you can decide what you want to share, where and with whom, and what kind of information and how much details, and also for how long. That's
Yeah.
all part of these frameworks we are using and the standards we are using. Absolutely. So you want to sign up for Twitch? Nobody is forcing you to use the identity you also use for work. You might be
Right.
able to do it if you choose to, but you don't have to, right? At some point in
Right.
time, you just have like a wallet with your identities or personas, and you choose what you want to use when. Of course, the service you want to use might have some requirements, right? So, for
Yes.
example, in certain cases, I want to be Hunter One for this service, but they only allow you to use this service if you can prove that you're older than 81 years old.
Right.
So think about if I have a verifiable credential from any of those trusted issuers, like in the US, the DMV for driver's licenses, or maybe
Right.
it's a government ID. I can choose, look, I want to sign up with this identifier or identity. I
Right.
can use a proof from this verifiable credential from one of these trusted issuers where I can prove I'm older than 18 years old, and I'm only going to share that kind of information. Then the service said, well, Christos, I know it's Christos, I know it's Hunter One. They did prove they're older than 18 years old by providing a proof. Now I'm going to allow you to sign up. Next time you come in with Hunter One, I know you proved that once, and I'm okay you using this service for now.
All right. So this takes me to the question that I'm unable to answer myself after reading all these things. So you gave a very good example. I get a verifiable credential by the DMV that can prove that I'm 18 and I can drive, right? Now I want to go to Walmart or Target and buy something, and I need to create an account. And I want to use that verifiable credential. How will the vendor, whichever vendor is, be able to use and verify that credential? So let's say I want to share my age because I want to buy alcohol, and I want to also provide my address as part of that verifiable credential. Will the vendor need to implement something that can hook into the DMV decentralized identity service to validate the credential?
They don't
No,
need
well,
to.
they can wave their hands, right? But yeah.
So they don't need to hook up something with the DMV
Okay.
to implement this. They need to have a mechanism that they can verify the credential that was issued to that subject.
Right.
So when a user is presenting a credential that was issued by DMV, all that
Yes.
Walmart has to do is to uh, uh, all that Walmart has to do is to make sure that the credential that is presented, it's a valid credential coming from a valid issuer. So
Okay.
as a verifier, I will do that validation using that public key, private key, PGP magic. And once I'm able to validate that credential, I can then take the claims that are there in the credential, like your name, your date of birth, and other details. And basis that, I can create an account for you. In all this, there is no federation between DMV and Walmart.
I see.
Let's make it real, because I think it's very abstract for folks now.
Yes.
Let's show what a verifiable credential is. It's not that
Yes.
complicated, and then we can talk a little bit about how this works as a flow between the different parties.
And we do have a few links that we can share. Is there any link that you want me to pop on the screen right now that matches to what you're going to show?
Rui, can you I will share my screen meanwhile.
I'll share my screen. I'm sharing it. 1 second.
No problem. Can you see my? I don't know. Can people see this?
Give me a second. Let me see. I can share now. There you go.
Right, there you go.
Okay.
So on the right side, this is just Authenticator. This is our wallet. We have this concept of a wallet where you can store verifiable credentials. I got a bunch of them here. For example, I'm the verified credential expert. This is just from our regular sample we have. And you can see there's some information in there. My first name, last name, when it was issued, by whom, a little description, some activity when I've been using this. So we store receipts. This is how we visualize a verifiable credential stored inside of the wallet.
Yep.
But what is a verifiable credential? Well, that's just an implementation of a W3C standard. In the end, it's just a job. This is what's stored in my wallet, and I use JOD.ms. You probably know this website. I should scroll in a little bit.
JOD is JWT. We had a lengthy discussion about how we pronounce it, but for people that want to go with JWT, it's JWT. But some people pronounce it JOD. So
JOD, JWT, JSON Web Token. A job token. I heard that one as well. And then,
oh, you have? Oh, well, it's like a PIN number, right?
It has a key ID, there's a header, and more important, there's a signature. We talk about it in a minute.
Yep.
But in the end, it's just a specific format. It gives you what kind of type, a verifiable credential, it's a verifiable credential expert, and this is an example from a troubleshooting video we did with double T. But this is the important piece. There's claims, like a first name, last name. I can check out if this verifiable credential is still valid. It might not be revoked. It tells you who issued the credential, and this is where DIDs come up. So the verifiable credentials, the structure where we tell you, like, look, there's claims. This is where you can find the status of this verifiable credential. There's a signature. We talk about it in a minute. And the DIDs are actually helping you identify who issued this and for who it is. So the subject is that one here. Oh, here it is. The subject is the DID of the holder. So this should be my unique DID. That means that the issuer gave the VC to this subject. And the signature should be from this issuer. The problem we have now when we have a decentralized system, typically this would be an ID token. There's a signature of this ID token. And how do you validate if that signature is correct? You go to the central IDP. There's a well-known endpoint where they publish their public keys. Typically, when you have this Microsoft Online.net with your tenant ID and all that stuff configured when you're using AAD or B2C, you go to the well-known endpoint, you retrieve the public keys, and you validate the signature by using that public key. we don't have a central point anymore where we have those public keys. And I guess that's the key part of like the did can be resolved. And I actually have an example here. If I resolve that did by pasting it here.
Can you zoom in a little bit? There you go, perfect.
It resolves to a bunch of information. Some service endpoints, that's the one you saw like not verified in my wallet.
Yeah.
But this one is key. It's a public key.
Yes.
So whenever I have a did, I can resolve that did to a did document, and that did document contains one or more public keys.
And I can use the public key to
verify the signature.
To verify. Okay, cool. I see.
So let me then explain this through a diagram, if that helps. So
yes.
You want to use this one? I can put it in this one.
Okay,
or the other one.
I don't know who's flipping now.
There you go. We will use Rohit's screen now.
Okay, yeah, perfect.
All right, so if you look at this diagram, there are three actors in the diagram. So there is an actor called Woodgrove. There is an actor called user, and there is an actor called verifier. So think of a scenario where user is employed at Woodgrove. User needs a verifiable credential so that user can then use it against an application. We talked about Walmart. Maybe they can use this example to gain some discounts or take some discounts by showing a proof of employment that I'm employed at Woodgrove. So as a user, I will go to Woodgrove and I'll ask Woodgrove, hey, Woodgrove, can you give me a verifiable credential that proves that I'm employed at Woodgrove? Woodgrove, in that case, can bring in an attestation model. It can say, hey, authenticate against a directory. It could be Azure AD, it could be Azure AD B2C, or it can be any OIDC provider. And once the user authenticates, user gets an ID token. The issuer service then can use that ID token, take the claims from that ID token, and then stamp it to the verifiable credential. So that could be one way of attestation. The other way could be user can be told, hey, I would like you to do an identity proofing journey. You have a driving license. Can you go to this independent software vendor site, do your identity proofing, and come back to me once it is verified? So as an issuer, I will take that information, stamp the claims in the verifiable credential. And if you see the first section of the diagram, the yellow highlights are important. It is issued. The issuer is did example employer. It is meant for a subject, which is did example user. And it is signed by the private key of the issuer. If you now recall what Matthias was showing, he was showing a JSON document, a did document with a did identifier. And in the document, you had public key material. So as a user, I was able to, I received a credential that was signed by issuer's private key. The issuer has submitted that public key material on the distributed ledger. Now, as a user, I am storing this credential in my wallet. Now that credential, I can have one credential from Woodgrove. I can have N credentials from Woodgrove. I can have multiple credentials coming from multiple issuers, and I can store it in my wallet. Now, as a user, I'm now ready to go to Fabricam and present my credential. Now, if you can see the second flow, in the second flow, do you see an extra line which says subject's digital signature?
Yes.
So when the user is now presenting this card to Fabricam, user is also signing the credential. And this talks about that concept of user is behaving like its own identity provider. User has signed the credential, and now the credential is at Fabricam. Fabricam will do a public key material lookup, do the public key private key matching. I'm sure most of you are aware of this PGP concept. So it'll do a public key private key match. It'll understand the credential, and once the credential is verified, it actually then takes the payload. And what's there in the payload? The claims, the title, and employed since. And basis that, Fabricam can then kick off a business process. Yep, I can offer you discount because you're employed at Woodgrove and you're employed since 2011. So that's the whole concept. There is no federation between Woodgrove and Fabricam. What Fabricam is doing is understanding the credential, doing a public key, private key match. Then if the credential is verified, it can then take the payload and then kick off the business process. Hope it makes sense.
Yeah, exactly. And that's what it is, right? We built a gigantic distributed, well, now it's like echoing. I tried to increase my volume because I heard some folks were complaining about the volume. So it's a big distributed PKI database. That's what makes this decentralized. Anybody in the world can resolve a DID to the document and get a public key. So whatever Woodgroup is signing with their private key, somebody on the other side of the world can verify without having to talk directly to Woodgroup. And that's kind of cool.
And that information is contained in the verifiable credential that we send out, right? So when the user signs that and sends it to...
No.
The verifiable credentials are using the DID identifiers.
Yes.
The DIDs can be resolved to this distributed database.
Yes.
And get the public key. So if there's a signature somewhere, like another Woodgroup signs the verifiable credential for the user, that signature can be validated by using that public key from Woodgroup. How do you get the public key? You go to this network. It's like almost like DNS for public keys, and anybody in the world can run such a resolver. It's very hard to, well, if at all, be able to block it worldwide. So, yeah, you run the world. I run a resolver at home. I can resolve that DID to a DID document. Inside of the DID document, I can find the public key, and I can make sure that the signature is actually correct.
Okay.
Yeah, Matthias, I think I see some questions like how we have implemented it. What's then the ledger? Are we implementing some open standards? Maybe let's talk about the standards. That way.
Yeah, you have the slide?
Yeah, let me just move to that one.
So there was a question about the validation of public keys. So it says, by validating the public keys and signature, can we determine if the token was tampered with?
Yeah, so I think that's the key issue here, right? So if somebody signs that JWT or JWT, by checking that signature, can actually prove, first of all, it's coming from this one issuer signer, and also that the document has not been tampered with.
Right. There you go. So tamper-proof.
And you could have like just the other way around, right? You could encrypt it with the public key of some party, and that is that party can then decrypt it because they own the private key, right? So
I see. Yeah. You're welcome to Giggles. And then, was there another question? Let me see. No, I think...
Yeah, so an Evelyn question, why would I use Microsoft? So we did not talk about what Microsoft is offering here. We will do that in a bit. Let's first go through what we actually built, right? And how it's done. Yeah. Because I think it's important to call out, like, what we are using, that it's not per se, it's not Microsoft technology. We did an implementation of public standards. So,
there's a Decentralized Identity Foundation, right? You can find that, I put the link down here, identity.foundation. So we're part of the consortium. We're not doing this in isolation.
Yeah, and this is a collection of different standards, right? Not only from the DIF, but also from W3C. So take, for example, you saw the JOT, the Verifiable Credential JOT. That's a standard way of storing verifiable credentials. That's a W3C standard. DIDs are a standard as well from the DIF. The user agent is implementing several standards. How we communicate between the wallet and the endpoints, that's based on OIDC SIOP v2. That's from the OpenID Foundation. So it's just a bunch of different standards we have to support to make all these things work. And those standards might be in different stages right now, right? So the W3C Verifiable Credential standard, that one is published and standard.
Yep.
User agent is a working implementation. It's not done yet. There's still some changes we have to do.
Sure.
So maybe just if I have to quote an example, things like how would backup and recovery work? That is something like a work item, and that's why it is in working implementation state. And there are certain standards we have not called out on this slide, But if you go to the documentation, we have standards like Decentralized, well-known configuration, which Matthias was calling out while he was doing a demo. That's also something we have implemented. Universal resolver, if you remember the previous diagram, when I was saying verifier will do a lookup of the public key material, it takes help of resolver so that it can get to the dead document and resolve it and get the public key. So that's where resolver comes in. There too, it is a working implementation stage, and it's all open standard and open source. So Matthias was saying he's running an iron node on his network. I'm running it on my Ubuntu VM. You can obviously run it as well. There's another object you see on the top left, Identity Hub. Think of it like a personal data store. What if you get an opportunity to store your verifiable credential at a temporary location that is owned by you, and then you can give access to apps? That share could be on OneDrive, Google Drive, it could be a share on your laptop. So that's
A publicly accessible endpoint, more or less, right?
publicly accessible endpoint, personal data store where you store your verifiable credential and you can then give access to apps. So think of Identity Hub as that, and it's also in working implementation.
So going back to this decentralized system, right? I see a bunch of questions on the chat as well. I hope my audio is much better now. Sorry about that. So what we are using is called IAN. What is IAN? IAN is a, I guess, level 2 protocol implementation on top of, in our case, Bitcoin. IAN is the side tree implementation on top of Bitcoin. So what do we store? So we store this DID document inside of IAN. What does that mean? IAN uses a bunch of different systems, but it uses a Mongo database and it uses IPFS for storage. And what we anchor on Bitcoin are the IPFS IDs. That's it. So we don't store information in that sense on top of Bitcoin. We store like IDs, anchor IDs of IPFS files on Bitcoin, and that's it.
So pointers, right? So the Bitcoin only owns the pointer to the IPFS document that stores the data.
Bitcoin is really well, like it's like a big clock, right?
Yep.
And you can't reverse that clock. So it's very robust, stable, and secure. It's permissionless, so no one single authority in the world can modify and change it. That's one of those reasons. But IPFS is the central database for storage of those DID documents. So whenever you talk to an IAN node, and I run one on Raspberry at home, it will find those identifiers and construct that DID document so you can find your private or your public keys and the endpoints. That's what it is.
Thank you for answering this one. Don't see any other questions. So let's go ahead with the rest of the architecture here.
So should we now show what we have implemented? What are the service components that we have? Visit the standard. Okay.
Yeah, everyone's dying to find out. I mean, at least I am dying to find out. So let's go.
Okay, so if you look at the slide, there are 3 sections on the slide. The first one explains the issuer interface. So as you start onboarding the verifiable credential service, you can be an issuer, you can be a verifier, you can be both. So you will get an interface on the Azure AD portal. As an issuer, you have this option of creating credentials. So this screenshot talks about how would you set up a credential. You will define a display file, like how your card should look like, black card with the Woodgrove logo, and how the label should be there when somebody clicks on the card to see the claim label. So that's how you would specify things in the display file. It's a JSON file. And then we have rules file, where you define that attestation model and claims mapping. If I'm telling the user to go and authenticate against a directory or the OIDC provider, I'm getting a ID token return. What claims I should take from the ID token, and how will it get mapped to the labels? That's what you would define in the rules file.
So I can totally customize this to take any claims that the IDP supports, like address and age and profession and whatever other information that we need to put into the verifiable credentials. Is that correct?
Yes,
Right.
it's a very flexible model, right? So you can
Mhm.
design, okay, somebody can self-attest information. I want this coming from an ID token if I talk to an IDP.
Yeah.
I want this to come from another verifiable credential as input. And there's different models, and what this interface helps you manage that all which comes around verifiable credentials, your private key, your DID, etc. So we have a management plane for your DID and your credentials, and we help you manage that. And of course, there's APIs to be able to talk to that, but that's the main promise. Like we have a management interface for all this stuff.
That's right. So just keep that point in mind. Like you can be an issuer, you can be a verifier, you can have both the roles. You need to onboard verifiable credential service when you're becoming a verifier as well. Now, for the developers, we have a Node.js SDK that has been on the public domain since April 2021. In September last year, we announced the request REST API, and that's what we are encouraging our customers and partners to use, because that takes off that burden of understanding the complexities of protocol, standards. You just make one API call to issue, one API call to verify, and you can choose your programming language. You can use Java, Node, Python, .NET, and then call the REST API, and you can build solutions with that. And on the end user side, you have a wallet, which is the Microsoft Authenticator app in our case. So if you now go back to the open standard slide, the user agent in our case is the Microsoft Authenticator app. We have the Azure AD verifiable credential service. As Matthias was explaining, this becomes like a management plane. We help you manage your DID, and then we also give you an interface where you can define your credentials. So that's a quick overview of our platform. So Matthias, should we talk about some use cases now?
Yeah, let's do that.
Yeah. I don't see any more questions that are open on the chat. So
No more questions.
yeah. So we have been working with customers and partners. As I said, this service went into public preview in April 2021, and we have received a feedback around 3 themes. Onboarding. Can we make onboarding of a user, that could be an employee, contractor, or vendor? Can we make that onboarding process fast, secure, and simple? Can we allow a model where users can have secure access to critical apps? And can this model support recovery options? Like, can we do self-service account recovery using verifiable credentials? These are some of the themes that we are seeing. And then basis that, we have done some 100+ pilots. There are some public documented case studies as well. Let's do this. Matthias, let's do a demo. Can we do a demo on this?
Yeah, let's do that.
Let's do that. Okay.
We got an onboarding demo we can show quickly. If that.
Yeah.
All right. Let me see. Share my screen. Which screen? Screen 2.
And I'm talking to myself because I'm muted. How fun is that? While Matthias is getting set up, I will urge everyone to go on the 425.show/VC-stream. I don't have a QR code, but go there and get your first verifiable credential. This is using the whole infrastructure that we're showing you, but you're gonna get a verifiable credential for the stream, which is super awesome. So try it now, and then let's go with the
Yeah,
flow.
do it. It's very easy. Chris has
Very
managed
easy.
to do it too. So
Hey, if I can, that's a very good point. If I can do it, then anybody can do it. In fact, the source code is available on GitHub as well. If you go to the 425 Show GitHub repo, All the source code is there, but we do have a lot of samples. We have samples on lots of languages, and the team has done a fantastic job to help you set up. You're probably going to be using these when you do the hackathon anyway, so make sure to check the samples and the docs.
So before I start showing the onboarding demo we have built, and everybody can actually do it, we'll share the link so you can do it and play yourself as well. Is what kind of scenarios, like generic scenarios, we see a lot as well. So I think a very good example of a decentralized scenario is what we see nowadays with those COVID passports or vaccination passports. And why is this a useful scenario? Is that there's a lot of different organizations who can issue those credentials, and there's a ton of other organizations who want to be able to verify those. But thinking about this, think if you want to be able to do this at worldwide scale, how do you do it? How do you maintain a list of, can you like do it centralized? There's that one authority where they can all get those issued. That's going to be hard to do. So this is a good example where a decentralized approach might be very, very useful. And for onboarding, it's the same, right? So we can do point solutions where I'm going to build this onboarding thing, but what if I want to start trusting things from outside of my organization? So we see Verifiable Credentials and decentralized technologies very very useful when you start crossing the domains. So, and again, I don't want to argue about if a vaccination passport is a good thing or a bad thing. I just want to make sure, like, you have to understand that if you want to implement these kind of solutions, what technology would be a suitable technology. So if you can switch to my screen, Christos.
Yeah, just give me a second. And by the way, we have a poll
and
running. We
type
have a poll
softer.
running. Yeah.
You're mad at
I
your
don't.
keyboard, man.
Yeah,
Why?
I'm sure his keyboard is cursing him.
Man,
Oh, it's a mechanical keyboard, so people are like, yeah, your typing is too loud, but it
No,
comes with the territory.
You sound mad at your keyboard. So the scenario here is that a new employee has to start at the organization, and in the past when we still were out and about, typically we have here at Microsoft here in Redmond, what happens? You show up in building 92. There's this security person who wants to see your government issued ID, and if everything checks out, they give you access to your account. Well, with remote work and people not showing up in the office, that's actually an issue. So how can we mimic that kind of scenario without being able to show up in person? So the scenario here is I'm a new employee for Woodgroove. I got an email to onboard. I'm Matthew Michael here. So, well, please welcome on board. Can you go through the steps to onboard at Woodgroove? Sure. And what they want me to do is prove my identity virtually, and I can do that by going to an identity verification partner. We have a fictitious one here, which is True Identity. What they typically do, they either ask you a bunch of questions or they ask you to take a selfie, upload a copy of your driver's license or your passport, the back and the front. Then they do some kind of magic, and I try to verify and make sure, well, this is actually Matthijs. Sometimes they do a liveness check, like you have to turn your head a few times and all that kind of stuff. So these companies do their magic and say, yep, we are very sure this is Matthew Michael. And I can actually now capture that proof through a verifiable credential. And so I scan the QR code. I enter the PIN. This typically would get to you through a different channel. I add the credential to my wallet. And now I have this True Identity verifiable credential in my wallet, which is actually the digital proof of that process I just went through. Now I return to Woodgroove. So, well, can you please confirm your identity? If you have done that process, sure, I can do that. I can scan the QR code again. If I would be on mobile, I would just have a deep link, right? I don't have to scan because how do you scan a QR code if you're on mobile? It asks me, do you want to present this proof to Woodgroove? It's actually a trusted or verified domain. So are you sure you're in the right place? Yes, I am. Allow this credential to be shared. Woodgroove does like, look up my DID, checks the signatures, does all this fancy stuff we just talked about, and everything checks out. I actually am successfully onboarded, and this is the proof. Look, you're onboarded, you proved your identity, welcome. The next part of this demo will be, well, you can retrieve a digital proof of your employment, your workplace credential here as well. Let's do that as well to complete this demo. Again, I scan a QR code. I want to pin again 4674. Add this credential to my wallet. And now I have a digital version of my workplace credential in my wallet as well. What's the first thing you typically are allowed to do when you join an organization? It's always the fun part, right? Get some hardware so you can do your job. Although nowadays it's kind of like, well, here's this loaner for the next 2 years before stock is get back, right? So don't be too mad because it's an old machine. But so Prosware in this case is like this supplier of hardware, and typically they have this corporate program where you can get the discounts. You have to sign up with your email address. You have to confirm these links, blah, 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 blah. They have this connection with all those systems. In this case, they actually done this with using Verifiable Credentials. So prove that you're one of our partners by supplying us with your workplace credential. And well, do you actually have a workplace credential? Yes, I do. This is one that's from Woodgroove. Share it. They will check if that's all correct, and it is. And then they will show you the corporate discount, and you can continue ordering. So this is very quickly a onboarding demo, and then after you've been onboarded, using your workplace credential to get a corporate discount.
So Matthias, the number one question that comes to me when I do this demo, does it need to be a QR code? Or what's there in the QR code? What happens in the QR code?
Okay, so what's technically happening under the covers when I scan a QR code, right? So based on the standards, what you have to do is you have to send instructions to the wallet. For example, you send instructions to the wallet. I want you to present me a workplace credential. And it can be very specific, right? I want you to present me a workplace credential from one of these two issuers. I want you to present me a driver's license from the DMV, a passport from the government, I don't know, or your I don't know, Home Depot loyalty card. And that request has to be packaged in a certain way and then sent to the wallet. What the QR code does is actually point the wallet to a specific spot on our services where that request has been stored. So whenever you use our APIs, oh, I want these verifiable credentials to be presented to me, the API transforms that request into a specific format. It's a JOT, as again, SIOP, OIDC SIOP v2 based. That request is stored on our server because it's it's too big to put in a QR code. What the QR code actually does is point you to that URL. So the QR code is nothing more than a URL to that request. The request is signed, so the wallet always verifies this is coming from a legit source. Does the DID lookup, make sure the signature checks and all that kind of stuff before it actually asks the user to present that information.
Great. So shall I show it through a Postman experience? So do you think it'll help?
Why is Christos muted?
Why am I muted? Because everyone's complaining about my keyboard, so I'm speaking to myself. I was saying, yes, please show us what happens behind the UI. And I would like to ask Bolt to stop breaking my application because he's hitting issues, networking issues and verifying issues. So I don't know what he's doing, but I should hire him as a tester because apparently my testing did not reveal any issues. So Bolt, you're hired.
So Christos, can you share my screen, please?
I shall share your screen, yes.
Thank you. So what Matthias was explaining, I'm just going to give you...
Can you increase the font size a little bit, Roy?
Oh yeah, man, it's like and
my
size.
God.
For this very old person.
Yeah, me too.
I'm gonna struggle now to.
Just no, you can do Control Plus, right? It's sorry, Command or Window Plus. There you go. More. Give me more.
Apple
And
Plus.
you can hide the sidebar, the navigation bar there.
Is this okay?
Magnifier, yeah.
Nope.
So what's Bolt doing? Why is it not working? Meanwhile,
Microsoft Magnifier
I'll look at the
500.
chat.
Okay, I think this should be good enough. Let me just show you a quick experience. So I have a bunch of post request configured Postman just to show you the experience. What I'm going to do, I'm going to show the issue experience. So as an issuer, I'm sending when a user is asked for credential, the issuance request is sent to the API with this payload. So the credential type that is being used in the issuance payload is verifiable credential expert. It is referring to a manifest, which is the contract URL. If you remember that display rules file concept that we're explaining, you saw in the demo there was a pin. So there is a pin payload as well, and we are supplying some claims. So when I would click on send to the API endpoint, by the way, it's an authenticated endpoint, so I have the access token for it. So let me on the authenticator app. If you see the response now, in the I had set include QR code value, which is the binary value, as true, and there is a that I got as a response, and see the screen, the QR code that we are talking about. So in Postman, you can do this trick to visualize the QR code. So let's just give this a few seconds. Come on. Do I have? Yeah. So I can scan this QR code.
Is that really slow?
Yeah, I don't know what's happening.
Okay. Your machine is crashing. Oh, there you go.
So I supplied the pin and I clicked on next, and I can click on add to accept this card in the wallet. And now if you look at the payload, there was a pin in the payload. And if I show you the response that came back from the API, so let's go back to the pretty tab. It gave me this URL as the response. And if you look at this request URI, this is what the QR code was presenting. So think of QR code like a facade, and it is pointing to this URL. The authenticator downloaded this URL. In that URL, there is a contract that is mentioned. The user downloaded this contract, which is this manifest file. In that contract, it was mentioned that there are claims like first name and last name. And to accept the card, the user had to supply the PIN. So this is what happens in the background for issuance. If I have to show you the presentation experience.
Yeah, this is where you want to verify a verifiable credential.
Yeah. Which some like vendors and stuff out there will be doing probably the verification rather than the issuance most times, right?
Yeah, that's probably like the 99% will be verifying, right?
Yeah.
Not issuing.
That's right. So I sent a payload to the API, and this is the presentation payload. Here too, if you look at the payload, I'm saying include QR code, which is a binary value. I've set it to true. For developers, you can work on this callback section. You can use this to refresh the messages on the screen. There's an authority value, which is the DID number of the verifier. You can see there is a section called registration, where I'm specifying the client name and purpose. And in the presentation section of the payload, I have specified that I'm asking you to present verifiable credential expert. Do you have that? So when I would look at this QR code, and I'll scan this QR code. what the wallet will do, wallet is going to the OpenID VC URL that we had. It'll download that URL and it'll go through this process. So if you look at this payload, in the payload, I've asked the user to present the verifiable credential expert VC, and I am saying that I will only accept if you present me this VC coming from this particular accepted issuer. So this kind of payload is something you can present. So you can think of scenarios where I can accept employee card if you're coming from Coca-Cola, but I will not accept an employee card if you do not have your data identifier mentioned in this accepted issuer list. So I accept employee cards from Coca-Cola, but not from Pepsi. That could be kind of a
Yeah,
scenario.
Why, man? What's wrong with Pepsi? Come on. You alienated
well,
half of our audience.
This is actually a good point Rohit brings up, right? So from a technical perspective, it's very easy. You just tell, give me this, like give me a workplace credential, and this could be an accepted issuer. But the question would be, well, how do we know who is a real organization? So think about, like, this is more like an industry problem we still have to figure out together with all the other parties as well. Like it's easy to develop against. We have a very easy to understand REST API. Conceptually, we're checking a bunch of signatures, right? So and we have a decentralized way of getting to those public keys. But how do you know what I can trust? How do I know who's the DMVs? What's the DMVs did? What's the governments did? What's the Coca-Cola, Pepsi's did? How do we build those different trust frameworks? And that's still something we have to do. Think about a digital diploma. That's great, right? I can prove that I actually have graduated with a bachelor's or master's, or no, I know how to tie my shoes. But how do you actually know in the rest of the world that you can trust this issuer issuing that diploma? I can give you a computer science degree with my issuer. That might not be as useful for organizations. So what we still have to do in the industry is come up with those different trust frameworks. Where do I find a list of DITs from real universities? And if there's an organization or maybe multiple organizations in the US, how do I know what's the one in Europe, right? Or in Greece, or in the Netherlands, or in the UK?
Yeah.
So building those different trust frameworks in the EDU space, in the workspace, the financial space, that's
Commercial
still
space
something
as
we have
well.
to do. Yeah.
And you just talked about the issuer thing. What about verifiers? They also need to make sure the VC that you're presenting is not a revoked VC, right? So refer to things like status list to see if it is a valid VC or not that you're trying to present to me. So on the verifier side also, they look for those checksums and see, yeah, you are coming from a valid issuer that I trust, and you are not presenting me an expired or a revoked VC. So those kind of things.
Still challenges there, right?
Yeah.
But I mean, that was great. I learned a bunch today, and I appreciate you two coming. Now, there's a QR code for people that might want to go and read about all the activities that we have this month. For people that just joined, thanks everyone for rating us, especially Lila for bringing her friends along. We totally appreciate that. We're just wrapping up talking about decentralized identity and verifiable credentials, but lucky you, everything is available on YouTube. So it will be available later on today, so you can go back and understand and look at what we talked about, why verifiable credentials and decentralized identities are important, especially as we move forward. I think Web3 is here to stay. It's not a fad anymore. So whether you want it or not, you need to start looking into this space, and Microsoft is doing that. So make sure to scan the QR code, to visit the blog by our CVP Sue Bond that wraps all the activities. All the content will also be posted there, so you can go and see that. Make sure to join our Discord community to ask any questions. And finally, on that same blog post, there will be the announcement for the hackathon that is happening on the 27th. What do you need to scan the QR code? I think the phones have if you go to the phone app, not the phone app, if you go to the camera app on your phone, it should prompt you to actually open that in your browser. So that's how it works these days. But yeah.
Yeah.
Yeah,
Send
QR
some
codes.
people.
There's been on this channel we had a whole conversation about QR codes, so everybody would know any QR code, any QR scanner will work, says Nick, but camera app on newer phones works. That's absolutely right. So I want to thank Matthias and Rohit for taking time from their busy schedule to come and talk to us. But we do have another one, another stream coming next week, same time. That is actually going to look into the behind the scenes APIs and how things work, and we'll look at some code, and we'll go a little bit more in depth about the workflow and how it's all set up. And then we have a number of blog posts about streams about you setting up your Azure Active Directory, which you can get for free through the Microsoft 365 developer program. And then on the 27th, you should have everything you need to build your own solution using verifiable credentials.